Science Salah Lotfi. Welcome to the For Science Salah Lotfi channel. We're thrilled to have you join us today. In today's episode, we will highlight two significant research studies published during Professor Dr. El Sayed Fathi's PhD program at Zagazig University in 2013. These studies have made remarkable contributions to their respective fields and have garnered much attention in the scientific community. Let's take a closer look at these important works, the methodologies used, and the esteemed researchers involved. We will explore the impact of their findings and how they have advanced our understanding in their areas of study. The first study is titled Mechanochemical Devulcanization and Gamma Irradiation of Devulcanized Waste Rubber, High-Density Polyethylene Thermoplastic Elastomer. This groundbreaking work was published in the Journal of Industrial and Engineering Chemistry in 2013. The study was a collaborative effort among several distinguished scientists. Professor Dr. El Sayed Fathi, Professor Dr. Medhat Hassan, Professor Dr. Raouf Okasha, and Professor Dr. Samia Abdel Al. These experts brought together their extensive knowledge and experience to explore new frontiers in polymer chemistry. All of these researchers are from the Department of Polymer Chemistry at the National Center for Radiation Research and Technology, Egyptian Atomic Energy Authority, Cairo, Egypt. Their collaborative work aims to advance scientific understanding and develop innovative solutions in the field of radiation research and polymer technology, contributing significantly to both national and international scientific communities. We also honor the late Professor Dr. Ahmed El Masri from the Department of Chemistry, Faculty of Science, Zagazig University, Egypt, who was an integral part of this research team. The second study is titled Styrene Butadiene-Based Blends Containing Waste Rubber Powder, Physico-Mechanical Effects of Mechanochemical Devulcanization and Gamma Irradiation. This study was also published in the Journal of Industrial and Engineering Chemistry in 2013. This study featured the same team of researchers: Professor Dr. El Sayed Fathi, Professor Dr. Medhat Hassan, Professor Dr. Raouf Okasha, Professor Dr. Samia Abdel Al. Stay tuned for the main video where we will dive into the details of these pioneering studies and their impact on waste rubber recycling. We will explore the innovative techniques and technologies being developed to transform waste rubber into valuable resources. Thank you for joining us today. Don't forget to subscribe to the channel for more insightful content and hit the notification bell to stay updated with our latest videos on cutting-edge research and advancements. See you soon.
Our planet faces a growing crisis. We are drowning in waste. Mountains of discarded materials grow higher every day. Among these cast-offs, rubber stands out as a particularly troublesome challenge. Rubber is essential. From tires to footwear, its uses are endless. But its durability comes at a cost. Discarded rubber takes centuries to decompose. It pollutes our land and our oceans. The need for innovative recycling solutions is more urgent than ever. In the heart of Egypt's Nile Delta, a scientist embarked on a mission. Professor Dr. El Sayed Fathi, a dedicated researcher at Zagazig University, recognized the magnitude of the rubber waste problem. He dedicated his career to finding a better way. Dr. Fathi understood that rubber recycling wasn't just about reducing waste. It was about reclaiming a valuable resource. His research focused on developing techniques to transform waste rubber into usable materials. He wanted to give discarded rubber a second life. Dr. Fathi's team focused on a process called devulcanization, a groundbreaking method in the field of rubber recycling. Vulcanization is what makes rubber strong and durable, giving it the resilience needed for various applications. It's a chemical process that creates crosslinks between rubber molecules, forming a robust network. These crosslinks are tough to break, making the rubber resistant to wear and tear. Devulcanization aims to break down these crosslinks, reversing the vulcanization process. This allows the rubber to be remolded and reused, significantly reducing waste and promoting sustainability. The team explored a novel approach, mechanochemical devulcanization, which combines mechanical and chemical techniques. This method uses a combination of mechanical force and chemical reactions to break down the rubber. The rubber is ground down into a fine powder, increasing its surface area. This increased surface area weakens the crosslinks, making them more susceptible to chemical agents. Then, chemical agents are introduced to the rubber powder. These agents further break down the sulfur bonds, effectively devulcanizing the rubber and making it ready for reuse in new products. Dr. Fathi's team didn't stop there. They knew that to truly revolutionize rubber recycling, they needed to explore every avenue. They turned their attention to gamma irradiation. Gamma rays are a form of high-energy electromagnetic radiation. They can penetrate deep into materials, causing changes at the molecular level. The team hypothesized that gamma irradiation could further enhance the properties of devulcanized rubber. By carefully controlling the dosage and conditions, they aimed to improve the material's strength, elasticity, and compatibility with other polymers. Section 5. A winning combination. Enhanced properties for recycled rubber. In 2013, Dr. Fathi's team published their groundbreaking research in their study titled Mechanochemical Devulcanization and Gamma Irradiation of Devulcanized Waste Rubber. High-density polyethylene. Thermoplastic elastomer sent ripples through the scientific community. The results were astounding. The combination of mechanochemical devulcanization and gamma irradiation had a synergistic effect. The treated rubber exhibited remarkable improvements in its properties. It was stronger, more flexible, and easier to process. The team had successfully turned waste into a high-value material. Section 6. Styrene butadiene rubber. Expanding the possibilities. Driven by their success, Dr. Fathi's team didn't rest on their laurels. They sought to expand the applications of their innovative recycling techniques. They set their sights on a new target, styrene butadiene rubber, or SBR. SBR is a synthetic rubber widely used in tires, footwear, and other products. It's known for its durability and resilience. However, recycling SBR presents its own set of challenges. Section 7. Real-world applications. From tires to construction materials. This section delves into the innovative ways recycled rubber is transforming various industries. The team's findings had far-reaching implications, showcasing the potential of recycled rubber in numerous fields. The enhanced properties of the recycled rubber opened up a world of possibilities, making it a versatile material for many uses. The recycled material could be used in a wide range of applications. These included, but were not limited to, tire manufacturing. The recycled rubber could be incorporated into new tire compounds, reducing the need for virgin materials and enhancing sustainability. Construction materials. The rubber could be used as an additive in asphalt, improving its durability, reducing noise pollution, and extending the lifespan of roads. Automotive parts. The recycled rubber could be molded into various components, such as seals, gaskets, and mats, providing cost-effective and eco-friendly alternatives for the automotive industry. Additionally, the recycled rubber could be used in playground surfaces and sports fields, offering safer and more resilient playing areas for children and athletes. Section 8. Towards a sustainable future. The impact of Dr. Fathi's research. Dr. Fathi's research marked a significant step forward in the quest for sustainable rubber recycling. His groundbreaking work has not only advanced scientific understanding, but also paved the way for practical applications. His team's innovative techniques offered a pathway to transforming waste into valuable resources. By developing new methods, they have shown how discarded rubber can be repurposed effectively. Their work has had a lasting impact. Scientific advancements. The research has led to numerous scientific advancements in the field of material science and environmental engineering. The studies provided valuable insights into the effects of mechanochemical devulcanization and gamma irradiation on rubber properties. These insights have been crucial in understanding how to improve the quality and durability of recycled rubber. Environmental benefits. The development of efficient recycling methods offered a solution to reduce rubber waste and its environmental impact. By minimizing waste, these methods contribute significantly to environmental conservation and sustainability. Economic opportunities. The use of recycled rubber in various industries created new economic opportunities and reduced dependence on virgin materials. This shift not only supports economic growth, but also promotes a more sustainable industrial ecosystem. Dr. Fathi's research continues to inspire further innovations and applications in the field of sustainable materials. Section 9. A call to action. Innovation for a greener tomorrow. The journey towards a sustainable future requires a collective effort. Dr. Fathi's groundbreaking research serves as an inspiration. It reminds us that innovation is key to overcoming environmental challenges. Let us continue to explore new ideas. Let us support research that pushes the boundaries of what's possible. Let us work together to create a greener, more sustainable tomorrow. The future of our planet depends on it.
Hey there, science fans. Have you ever wondered what happens to old tires, or those worn-out rubber toys? We use a lot of rubber and most of it ends up in landfills. That's a big problem for our planet. Rubber takes up space and can release harmful chemicals into the environment. But what if we could give that old rubber a new life? That's where the magic of recycling comes in. Scientists are finding innovative ways to turn waste rubber into useful materials. This isn't just about less trash, it's about protecting our planet for future generations. Think about all the things we use rubber for: car tires, shoes, hoses, and so much more. Recycling rubber isn't just a good idea, it's essential for a healthier and more sustainable future. Let's explore how researchers are tackling this challenge and making a real difference. Okay, science enthusiasts, let's get technical for a moment. Before we can transform old rubber, we need to break it down. Rubber products are often vulcanized, meaning they've been treated with sulfur to make them strong and durable. To recycle rubber effectively, we need to undo this process, and that's where mechanochemical devulcanization comes in. Picture this: a powerful machine called a two-roll mill. It has two rotating rollers that generate heat and pressure. When we feed waste rubber into this machine, something amazing happens. The mechanical shearing forces, combined with a bit of heat, start to break the sulfur bonds in the rubber. This process, known as mechanochemical devulcanization, is like giving old rubber a fresh start. It transforms the rubber from a tough, cross-linked material into something more pliable and easier to work with. It's the crucial first step in giving waste rubber a new purpose. Now that we've broken down the old rubber, it's time to get creative. Scientists have discovered that blending this devulcanized rubber with other materials can create something entirely new and useful. One exciting approach is to mix it with a common plastic called high-density polyethylene, or HDPE for short. You encounter HDPE every day. It's in milk jugs, detergent bottles, and even some cutting boards. By blending devulcanized rubber with HDPE, researchers are creating a type of material called a thermoplastic elastomer, or TPE. TPEs are known for their flexibility, durability, and ability to be melted and reshaped. Imagine the possibilities. This blend of recycled rubber and plastic could be used to create everything from flexible phone cases to durable outdoor furniture. It's a fantastic example of how innovative recycling can turn waste into valuable resources. Hold on to your lab coats, science buffs, because things are about to get even more interesting. While blending devulcanized rubber with HDPE is a great start, researchers have found a way to make this new material even stronger and more resilient gamma irradiation. Don't worry, it's not as scary as it sounds. Gamma irradiation is a safe and controlled process that uses high-energy gamma rays to modify materials at a molecular level. When the rubber-plastic blend is exposed to gamma irradiation, something remarkable happens. The gamma rays create cross-links between the rubber and plastic molecules, essentially welding them together more tightly. This process significantly enhances the mechanical properties of the material, making it even stronger, tougher, and more resistant to wear and tear. It's like giving our recycled material a superpower, making it suitable for even more demanding applications. Section 5. Testing the results. Stronger and more flexible. Now for the exciting part, putting our newly created material to the test. Scientists conducted rigorous mechanical tests to see how well the gamma-irradiated rubber-plastic blend performed. They measured its tensile strength, which is its ability to withstand being pulled apart, its elongation, which is how far it can stretch before breaking, and its hardness, which is its resistance to indentation. The results were impressive. The gamma irradiation significantly improved all three properties. The material was stronger, could stretch further without breaking, and was more resistant to damage. These improvements make it an even more versatile and valuable resource for various applications. Imagine using this material for products that need to be both strong and flexible, like durable hoses, waterproof seals, or even impact-resistant phone cases. The possibilities are endless. Section 6. A closer look. Analyzing the new material. To truly understand the magic happening at a molecular level, scientists used advanced techniques to analyze the rubber-plastic blend. One technique, called Fourier Transform Infra-Red Spectroscopy, or FTIR, helped identify the chemical bonds present in the material. Another technique, Thermogravimetric Analysis, or TGA, measured how the material's weight changed when heated, providing insights into its thermal stability. Finally, Scanning Electron Microscopy, or SEM, allowed researchers to visualize the material's surface at a microscopic level, revealing its structure and morphology. These analyses confirmed the success of the recycling process. They showed that the devulcanized rubber and HDPE were well blended, and that the gamma irradiation had created the desired crosslinks, resulting in a material with enhanced properties. Section 7. A giant leap for recycling, a greener future. The research on recycling waste rubber into eco-friendly materials has far-reaching implications for a greener and more sustainable future. By diverting waste rubber from landfills, we reduce pollution and conserve valuable natural resources. Creating new materials from recycled rubber also reduces our reliance on virgin materials, which often have a significant environmental footprint. This research is a testament to human ingenuity and our ability to find innovative solutions to pressing environmental challenges. It shows that we can turn trash into treasure, reducing waste and creating valuable products in the process. This is a win-win situation for both our planet and our economy. Imagine a world where recycling is the norm, where waste is seen as a resource, and where innovation drives us toward a circular economy. This research brings us one step closer to that vision. Section 8. Join the recycling revolution. This groundbreaking research is incredibly exciting, but it's just the beginning. We need your help to spread the word about the importance of recycling and supporting innovative research like this. Every action counts, from properly disposing of your waste to supporting companies committed to sustainability. Share this information with your friends, family, and on social media. Let's make recycling cool, trendy, and most importantly, the norm. Together, we can create a brighter future for our planet, one recycled tire at a time. Remember, every small action we take to reduce, reuse, and recycle makes a difference. Let's all do our part to protect our planet and ensure a healthy and vibrant future for generations to come. Section 9. The science behind the solution. You might be wondering, what makes this recycled rubber blend so special? The answer lies in the unique properties of both rubber and HDPE. Rubber, known for its elasticity and resilience, provides the blend with flexibility and durability. HDPE, a strong and versatile plastic, adds strength and structural integrity. When combined, these two materials create a synergy that's greater than the sum of its parts. And that's where gamma irradiation comes in, further amplifying these properties. By inducing crosslinks between the rubber and plastic molecules, gamma irradiation creates a more tightly bound and robust material. Think of it as weaving the rubber and plastic strands together more tightly, making them almost inseparable. Section 10. Looking ahead, more discoveries await. The journey doesn't end here. This research opens up a world of possibilities for further exploration. Scientists are already investigating new ways to optimize the recycling process, experimenting with different types of rubber and plastics, and exploring the potential of other radiation techniques. Imagine using this technology to recycle other types of waste, creating a closed-loop system where waste is continually transformed into valuable resources. The potential for innovation is limitless. This research is a reminder that science is a continuous process of discovery and innovation. By pushing the boundaries of knowledge, we can find creative solutions to some of the world's most pressing challenges. Section 11. Turning trash into treasure. A global effort. Recycling is not just a local issue. It's a global challenge that requires collaborative efforts from individuals, communities, and nations around the world. By sharing knowledge, resources, and best practices, we can accelerate the transition to a more sustainable future. Imagine a world where waste is no longer seen as a burden, but as a valuable resource. A world where landfills are replaced with recycling plants, and where innovation drives us toward a circular economy. This research is a shining example of what we can achieve when we work together toward a common goal. Let's continue to support scientific research, promote sustainable practices, and inspire others to join the recycling revolution. Together, we can make a difference.
Hey there, science fans! Today we're diving into the fascinating world of rubber recycling. We use rubber for everything from car tires and shoe soles to hoses and seals. It's a versatile material, but it also presents a unique challenge when it comes to recycling. Unlike some plastics that can be melted down and reshaped, rubber is a bit more stubborn. You see, rubber is made up of long chains of molecules that are tightly cross-linked, like a tangled mess of spaghetti. This cross-linking process is called vulcanization, and it's what gives rubber its strength and elasticity. The problem is, once rubber is vulcanized, it's difficult to break those cross-links and recycle it back into its original form. But fear not, science is on the case. Researchers are developing innovative methods to devulcanize rubber and give it a new lease on life. Let's explore two of these exciting technologies: mechanochemical devulcanization and gamma irradiation. Get ready to have your minds blown by the power of science. Imagine taking those old discarded tires and grinding them down into a fine powder. That's the first step in mechanochemical devulcanization, a process that uses mechanical energy to break down the crosslinks in rubber. It's like giving those tangled spaghetti strands a good shake. By applying shear forces through grinding, milling, or other mechanical processes, we can actually break those stubborn sulfur bonds that hold vulcanized rubber together. But wait, there's more. Mechanochemical devulcanization doesn't just break down the rubber, it also creates reactive sites on the rubber molecules. These sites are like open arms, ready to form new bonds with other materials. This opens up a world of possibilities for creating new and improved rubber products. Think of it like this. We're taking apart an old Lego structure and then using those same Lego blocks to build something entirely new and even better. Pretty cool, right? Now, let's talk about thermoplastics. These amazing materials are like the superheroes of the plastic world. Why? Because they can be melted down and reshaped multiple times without losing their properties. Think of your favorite plastic toys or containers. Many of them are made from thermoplastics. So, what do thermoplastics have to do with rubber recycling? Well, remember those reactive sites we created through mechanochemical devulcanization? Those sites are just begging to bond with something new, and thermoplastics are the perfect partners in crime. By blending devulcanized rubber with thermoplastics, we can create new materials with enhanced properties. It's like combining the strength and flexibility of rubber with the versatility and processability of thermoplastics. The result? A whole new generation of sustainable and high-performance materials. Section 4, Radiation Processing of Polymers, a powerful ally in recycling. Now let's talk about gamma irradiation. Don't worry, it's not as scary as it sounds. Gamma rays are a type of electromagnetic radiation, similar to X-rays, but with even more energy. When we expose polymers like rubber to gamma irradiation, something amazing happens. The high energy of the gamma rays can actually break and reform chemical bonds within the material. This can lead to some really interesting and beneficial changes. For example, gamma irradiation can improve the strength, flexibility, and heat resistance of polymers. It can also enhance their compatibility with other materials, making them easier to blend and recycle. It's like giving our rubber a superpower boost. By harnessing the power of gamma irradiation, we can take recycled rubber to a whole new level of performance and sustainability. Section 5, Meet the Materials Waste Rubber and HDPE. In our quest to create amazing recycled rubber products, we need the right ingredients. First up, we have our star player waste rubber. This can come from various sources like those old tires we talked about, but also from industrial waste streams. Next, we have our trusty sidekick, high-density polyethylene, or HDPE for short. You probably know HDPE best as the plastic used to make milk jugs and detergent bottles. It's strong, durable, and easy to process, making it a perfect partner for our recycled rubber. Together, waste rubber and HDPE form a dynamic duo, ready to be transformed into something truly extraordinary. But first, we need to put them through our special recycling process.
But it needs recycling. Hey there, science fans. Rubber is everywhere. From the tires on our cars to the soles of our shoes, it's a vital material. But here's the thing. Used rubber can be a real pain to deal with. It doesn't decompose easily, and it piles up in landfills. That's why recycling rubber is so important. We need to find ways to give this amazing material a second life. One of the biggest challenges with recycling rubber is that it's vulcanized. Vulcanization is a process that makes rubber stronger and more durable. It does this by creating chemical bonds called crosslinks between the rubber molecules. Think of it like weaving a net. The crosslinks are like the knots that hold the net together. The downside, these crosslinks make it tough to melt and reshape the rubber. That's where mechanochemical devulcanization comes in. It's like untying those knots in the rubber net. By applying mechanical energy, we can break down those pesky crosslinks, allowing us to recycle the rubber more easily. So how does mechanochemical devulcanization actually work? Imagine putting your used rubber in a giant blender with some special ingredients. That's kind of what's happening. We use a machine called a twin screw extruder. It churns and grinds the rubber, breaking those crosslinks. But it's not just about brute force. We also use clever chemistry to help the process along. Scientists use a technique called FTIR analysis to see how effective the devulcanization is. FTIR stands for Fourier Transform Infra-Red Spectroscopy. Don't let the long name scare you. FTIR analysis shines infrared light on the rubber and measures how much light passes through. Different types of chemical bonds absorb different amounts of light. So, By looking at the pattern of absorbed light, scientists can tell if the devulcanization process has broken those crosslinks. It's like using a special flashlight to see inside the rubber. The proof is in the pudding, or in this case, the recycled rubber. After devulcanization, we can test the rubber to see how its properties have changed. One important property is tensile strength, which measures how much force a material can withstand before it breaks. Think of pulling on a rubber band. The stronger the band, the harder you have to pull. Another key property is elongation at break. This tells us how much we can stretch the rubber before it snaps. Imagine stretching that rubber band again. The higher the elongation at break, the farther you can stretch it. The results? Devulcanized rubber shows significant improvements in both tensile strength and elongation at break. This means the recycled rubber is stronger and more flexible. Seeing is believing, right? To really understand how devulcanization changes the rubber, scientists use a powerful tool called Scanning Electron Microscopy, or SEM for short. This technique uses a beam of electrons to create detailed images of the rubber's surface. The SEM images reveal that devulcanized rubber has a much smoother and more uniform surface compared to the original rubber. Remember those crosslinks we talked about? They create a rough, irregular surface. Devulcanization smooths out those irregularities, making the rubber more cohesive. This smoother surface is one of the reasons why devulcanized rubber has improved mechanical properties. It's like the difference between trying to build something with rough, jagged blocks versus smooth, even bricks. The smoother the surface, the stronger and more stable the structure. Section 5. Mixing it up. Blending recycled rubber with HDPE for enhanced materials. Here's a cool trick. We can blend our recycled rubber with other materials to create something even better. One popular option is high-density polyethylene, or HDPE. You know those sturdy plastic bottles and containers? Many of them are made from HDPE. When we blend devulcanized rubber with HDPE, we create a composite material with enhanced properties. The rubber adds flexibility and impact resistance, while the HDPE provides strength and rigidity. It's like combining the best of both worlds. These blends have a wide range of potential applications, from car bumpers and floor tiles to playground surfaces and even roofing materials. Section 6. Taking the heat. Thermal analysis of recycled rubber blends. We need to make sure our recycled rubber blends can handle the heat, literally. Scientists use thermal analysis techniques like Thermogravimetric Analysis, or TGA, to study how these materials behave at different temperatures. TGA measures the weight loss of a material as it's heated up. This helps us understand its thermal stability and decomposition behavior. We don't want our recycled rubber products melting on a hot day. The good news is that recycled rubber blends with HDPE generally show excellent thermal stability. The TGA results confirm that these blends can withstand high temperatures without significant degradation, making them suitable for a wide range of applications. Section 7. The gel effect. Understanding cross-linking in recycled rubber. Remember those crosslinks we talked about earlier? They play a crucial role in determining the properties of rubber. Even after devulcanization, some degree of cross-linking remains in the recycled rubber. Scientists use a technique called gel fraction analysis to measure the amount of cross-linking in the rubber. The gel fraction represents the portion of the rubber that is insoluble, meaning it won't dissolve in a solvent. The gel fraction gives us valuable insights into the properties of the recycled rubber. A higher gel fraction indicates a higher degree of cross-linking, which generally leads to increased strength and stiffness. Section 8. Gamma power. Using radiation to improve recycling. Now, let's talk about gamma irradiation. It sounds like something out of a comic book, but it's a real and useful technique in rubber recycling. Gamma irradiation involves exposing the rubber to high-energy gamma rays. Don't worry, the irradiated rubber isn't radioactive. The gamma rays break down some of the remaining crosslinks in the rubber, making it easier to process and blend with other materials. Gamma irradiation can also improve the properties of the recycled rubber. For example, it can increase its tensile strength and elongation at break, making it even stronger and more flexible. Section 9. A sustainable future. The promise of recycled rubber. Recycling rubber isn't just good for the environment, it's also good for business. As we continue to develop and refine these recycling technologies, we can create a more sustainable future by reducing waste, conserving resources, and developing innovative new materials. The possibilities are endless. By understanding the science behind rubber recycling, we can unlock its full potential and create a world where this amazing material is used more responsibly and efficiently. So, next time you see a rubber band or a tire, remember the incredible journey it can take through the world of recycling.